Welcome students. In this video we'll discuss part 3 of unit 1. We are discussing about angle modulation as well as the overall modulation techniques questions, possible questions. So the angle modulation index of FM. In angle modulation we have two types of modulations. One is phase modulation and other is frequency modulation. So out of these two the frequency modulation is more important. And the modulation index of FM, that is the frequency modulation, it is defined as MF, which is equal to frequency deviation by modulating frequency. And in equation you can write it like this: MF is equal to del F divided by FM, where del F is nothing but the frequency deviation, FM is the modulating frequency. For calculating the frequency deviation you have to use the formula Kf into Vm, where Kf is deviation sensitivity. Most probably they will give this value Kf, the deviation sensitivity, and Vm is the modulating signal voltage, right? So to calculate del F, the frequency deviation, we need to know the deviation sensitivity and the modulating signal voltage. And dividing this with the modulating frequency, you will get what it is, the modulation index of FM. Okay, so the next one is the bandwidth of narrowband FM. In FM we have two kinds of categories. One is narrowband and other is wideband. So in narrowband FM the bandwidth is calculated as 2 times of FM, as like your normal AM. And then in wideband FM the bandwidth is 2 times of del F. These are some important formulae. And another very important formula is Carson's rule. So Carson's rule defines the bandwidth as 2 times of del F plus FM. Okay, so 2 times of del F plus FM, where del F is actually, you know, the frequency deviation. FM is the modulating signal frequency. So based on these problems, if they are asking problem in FM, so most probably you will get the problem on these topics by using these formulae. So for example, we will discuss one problem. Determine the peak frequency deviation and modulation index for an FM modulator with a deviation sensitivity Kf given and a modulating signal it is given as Vm of t. So for this you have to solve what is the frequency deviation, peak frequency deviation or frequency deviation, both same. So del F and modulation index MF you have to find. So the del F is equal to Kf into Vm. Kf that we already know, Kf sensitivity and Vm is modulating signal voltage. So sensitivity is given directly as Kf in the question itself, and Vm we don't know, so that Vm is nothing but the modulating signal voltage. So by referring this equation you can say the first term in this equation, so that is the Vm value, because it is represented in time domain, and we know that the general signal format is Vm cos 2 pi omega t. So the first place stands for the voltage of the signal. So 2 is the voltage we have taken here. So Kf, the sensitivity, into the 2 volts, multiplying, you get the del F as 10 kilohertz. So del F is actually a frequency term, so you will get kilohertz answers. And following this, the MF value. The this is the modulation index of frequency modulation. So MF is nothing but del F by FM. So since you have got del F, so just substitute that del F and divide it by the FM value. So now the question is, what is the FM? It is not given directly. So again go to this equation. So this is the standard equation for the FM signal, that is the modulating signal. So in this 2 pi FCT, the original format of the expression is cos of 2 pi FCT. So in place of FC what you have is 2000. So 2000 is your FM. So by replacing the 2000 value here, that is 2 kilohertz, you finally find the value MF as 5, modulation index value 5. And the next question is again a simple question. What is the modulation index of an FM signal having carrier swing of 100 kHz when the modulating signal has frequency 8 kilohertz. So clearly you first understand the data given are carrier swing and FM. FM is the modulating frequency. Carrier swing given as 100 kilohertz. So first understand students, carrier swing is nothing but 2 times of del F. Okay. For calculating the modulation index, if you want to calculate the modulation index, that means you want to calculate MF. So the formula is del F by FM. But we don't have the del F value directly. We have only the carrier swing. So the carrier swing is nothing but 2 times of del F. So from that carrier swing, first you calculate the del F value. So del F is equal to carrier swing by 2. Carrier swing is given here as 100 kilohertz. So divided by 2, you get 50 kilohertz answer. And now use this del F value for calculating your modulation index. Already FM is also given. So by substituting, you get the modulation index value. So this is an example problem for calculating the modulation index if carrier swing of the signal is given. Carrier swing is nothing but 2 times of del F. That you should remember. And regarding the problems we discussed so far, and now so this is a comparison table of amplitude modulation systems, various amplitude modulation, a very important thing, because when they are asking it as MCQ type of questions, so they may ask questions like comparison, like the bandwidth of AM signal. See, for example, if you take the bandwidth, so in this table all the data are given comparably, like what is the bandwidth for normal AM signal and DSB AM signal, SSB AM signal and VSB AM, because in AM we have all 4 categories. So while studying this table, you can easily identify the bandwidth is less in the case of SSB, single sideband suppressed carrier. Okay, because there is only one band, so only one sideband is used. And in vestigial sideband AM, the bandwidth is between FM and 2FM. Okay, that means it is greater than FM value and it is less than 2FM. That is in between FM and 2FM the value lies. And power saving, so the power saving takes place, a very good power saving happens in SSB. You could notice this, 83.3% of power is saved here, SSB. Then the next power saving happens with VSB. Then third is DSB. The normal AM signal has power saving is very less, that is 33% only. And power saving for non-sinusoidal, so like the same way it is compared. And the generation method, while generating the signal, it is more, the normal AM signal is very easy to generate. DSB SC is not difficult one, but the SSB is very difficult to generate, and as well as the VSB is also difficult, but compared to SSB it is easy only. And the detection methods comparingly, normal AM is simple and inexpensive, the DSB SC is difficult, and the third category SSB is more difficult, VSB is somewhat difficult. And like that, the signal to noise ratio and all not that much important for you. Sidebands, so this is another important thing. In normal AM it has 2 sidebands. In DSB SC it has 2 sidebands. In SSB only 1 sideband. In VSB one of the sideband is partially suppressed and a vestige of other sideband is transmitted. Okay, so this is the thing happens in VSB. And in application wise, because you may get a lot of questions based on application. So application wise, the public communication system broadcast, that is normal AM is used in public communication system, that is AM broadcast applications and all. And DSB SC is used for short distance point to point communication. And SSB is highly useful for the audio communication, that is a long range of high frequency communication, especially in audio communication. And the final VSB is mainly used in television transmission. So this is a very important application based comparison. So the television based transmission, for that purpose VSB is used, because by the way of application they may ask some questions like this. And the next category of comparison we are going to discuss is wideband and narrowband FM. So in FM these two are the categories. So and the difference that you must learn are, first thing, the modulation index is, in wideband FM the modulation index is greater than 1. Okay. You know in AM the maximum modulation index will be 1. But in FM it is not like that. You may get even greater than 1 values for wideband FM if it is wideband. If it is narrowband FM, the modulation index will be less than 1. And the maximum frequency deviation for wideband is 75 kHz, narrowband is 5 kHz. And the range of modulating frequency for wideband FM, the modulating frequency must be 30 Hz to 15 kHz. Narrowband 30 Hz to 3 kHz. And similarly the bandwidth calculation. So generally the wideband FM is 15 times higher bandwidth than narrow bandwidth. Okay. So already I have given the formula for this. So you can have a comparison. And then the pre-emphasis and de-emphasis are needed in both the cases. And in wideband FM the noise is suppressed more than the narrowband. In narrowband the noise is less suppressed. Application wise, so this is very important point you have to notice. Application wise, the wideband FM is highly useful in entertainment broadcasting, that can be used for high quality music transmissions. It is used, the wideband. Narrowband FM is used in FM mobile communication like police and wireless ambulances. So in this communication the narrowband FM is used. So application wise question definitely you can expect. So study this table once again so that you can find some comparisons between the normal wideband FM and narrowband FM. Okay students, so with this we will conclude this problems and some comparisons based analog modulation. So in analog modulation, so these are the important highlight things that I want to discuss, and we'll discuss the remaining things in the next coming videos. Thank you students.